Okay, we're going to finish up by finding the equation of the tangent line to the graph of this given function at the point P order pair 1, 2. So first of all, let's just start with our function e to the x plus 3 times the natural log of x plus 2. And the first thing we're going to do is take the first derivative of that. So y prime is going to be what's going on here. Good. So we have to do first times the derivative of the second plus second times the derivative of the first, just showing all steps. Okay, now we're moving on. Let's proceed on. What's the derivative of 3 natural log of x? We just have the 3. What's the derivative of natural log of x? Just 1 over x, right? And what's the derivative of 2? It's just going to be 0. So I don't have to write anything there. All right, let's work on simplifying this. So we just have x minus 1. What is the derivative of e to the x? Just e to the x. Good. Plus, let's carry down e to the x. And what is the derivative of this term? Just 1. Just simplify this through. This is going to be x minus 1 e to the x plus e to the x plus 3 over x. Okay, that looks like as simplified as I can get my first derivative. Now we want to evaluate that at x equals 1 because we have the point that was given to us. So we want to know y prime at 1. So y prime is everywhere there's a x, I'm going to put in a 1. So I have 1 minus 1 e to the 1 plus e to the first power plus 3 divided by 1. So all I did was take this first derivative and evaluate it when x is 1. So everywhere there's an x, plug in a 1. And y prime at x equals 1 is going to be, well, 1 minus 1 is just 0. So 0 plus e to the first power plus 3. So the first derivative at the point P when x equals 1, we're just going to get e plus 3. So this is the slope of the tangent line. This represents the slope of the tangent line. They want us to find the equation, so we got to go one step further. This is going to be that's the slope of the tangent line at the point x equals 1. Well, where x equals 1. On the next page, we'll finish out the equation. So using the equation, use our point slope form. Y minus y1 equals mx minus x1. Okay, we recall that. We were looking at the point. Let me write it over here. What was it? 1, 2. So the y value is 2. And what did we get for our slope on the last page? E plus 3 was our slope. And then we have x minus, what's our x value? Of 1 there. So we just get y minus 2 is equal to e plus 3 times x minus 1. Add 2 to both sides, trying to get y equals by itself. So y is equal to, if you distribute this out, let's go ahead and FOIL it out. E times x minus e plus 3x minus 3, and then of course I have that plus 2 that we moved over from the other side. So y is equal to e to the x minus e plus 3x, then those simplify to minus 1. Okay, now this doesn't look necessarily like slope-intercept form, so what we can do is try to group our x terms so that we can simplify this a little bit better. This is just doing some work. So if I rearranged it to put my x terms next to each other, I would just put this term next to this term, and then the other two that are left are minus e minus 1. So if you remember some grouping, we can factor out common terms out of each one of these groups. So y is equal to, pull out an x, this is going to be e plus 3. And then if I pull out a negative 1, I just get e plus 1. So y is equal to, if you plug this in your calculator, e to the first power plus 3, you should get approximately 5.72x. And then if you plug this into your calculator, when you simplify it, e plus 1 and then multiply it times a negative 1, you should get approximately 3.72. So this is the equation of the tangent line at the graph at the particular point 1, 2.